In this example problem, we are going to build a confidence interval for a bunch of information that we have in a sample. When we don't know what the population standard deviation is, we don't know what sigma is. And because we don't know what sigma is, we're going to have to do t-values, if you will. We're going to have to use our t critical value. And since we don't have the population standard deviation, we're going to have to sub in the sample standard deviation. So what is the question we are asked to figure out right here? We're going with Amazon Prime. I'm pretty sure everybody's familiar with them. Amazon's premium service gets you free shipping, gets you 5% off when you buy stuff that's Prime labeled. You get to stream TV shows. It's a good service. We have an information over here about the average amount spent by a selection of 100 different Prime customers. So we have 100 customer feedback and how much they spent in the last year using their Amazon Prime. We are asked to take this sample and make a prediction about the population, which in our case would be all Prime customers. Based upon the sample, how much can we say with 95% confidence the average Prime customer spends in a year? Well, the first thing we're going to need is our sample size. So to find our sample size, the question says it's 100. You could just type it in. I'll be thorough and use my count A function of the customers that we have. So count A of column A tells me that, yep, indeed, there's 100 people in the sample. How much did the sample of 100 people spend on average? Well, customer 1 spent $12.72, customer 2 spent $10.89, so on and so forth. Add those all up, divide by 100, you get the average. Or I could just do it using the average function. So I want the average of all of these different expenditures. Everything in column B. And we find with that information that the average person in this 100 Prime customer sample spent $1,306.94 last year. To construct our confidence interval, we're going to have to take find our t critical value, which is basically a number that has to get inputted in our formula because we need something to represent what level of confidence we are working with. We did this in a previous question where we had a z distribution and we used the norm.in function. We can't use that here because we don't know for certain that our information is going to be normally distributed because we don't know the full population standard deviation. We're going to have to use the sample standard deviation. So that's the case. I can't use the norm.in function. I'm going to have to use the t.inv function. So t.inv. Hit go. And you'll see that there's a couple of them. We just want the regular one that says t.inv. And I'm going to hit OK. It's going to ask me for two things. Firstly, the probability. If we're 95% confident, that means that we have 5% unconfidence, for lack of a better word. And of that 5% that we are unconfident, we're saying that 2.5% of the time it's going to be below our predicted range. And 2.5% of the time, the true population mean is actually going to be above our predicted range that we're making a guess for. Well, we only want to capture one of those missing areas, one of those missing 2.5%. So my probability that I'm going to have is 0.975. And then the second thing I need is my degrees of freedom. Because we don't know an statistic about, say, a parameter, about the entire population, we got to have some kind of way to factor in the truth that the bigger our sample is, the more accurate it probably is a predictor of the entire population. And that's what degrees of freedom does. And the formula for it is n, your sample size, minus 1. So our sample size was 100 minus 1. And you'll get different values of a return based upon your sample size in here. That helps, put confidence in your interval. Sorry for the pun. Because you have a sample that you think is accurately big enough to be able to truthfully predict the entire population. So all in all, when I put that in, I get a t critical value of, all just froze up. What is that? There we go. Okay. I get a t critical value of, sorry about that, it's 1.9842. And it's probably even more numbers than that, but we'll round off to that point. And we need that just purely for our calculation. Sample standard deviation, because we don't know the population standard deviation, we got to use the sample standard deviation, and that formula, if I go back to insert formula over here, is stdev.s. So I hit go, and I come and I get my standard deviation of a sample, which is going to be the standard deviation of all the annual expenditures that we have recorded. And I drag that down and I hit OK, and I come up with $336.14. Pretty big standard deviation. What we're saying here is that the majority of our people in our sample spent somewhere between $336 less than $13.06 and $336 more than $13.06. Now, what lastly is our margin of error going to be? And our margin of error we are going to find in the following way. The first thing that we're going to do is we are going to have it be equal to the T critical value that we had before, 1.9842, etc., times, open a parenthesis, your sample standard deviation divided by the square root, SQRT, open another parenthesis, of your sample size. And this is the formula for how you always find a margin of error for your sample if you're doing the T method. It's always going to be equal to T critical times our sample standard deviation divided by the square root of our sample size. And our margin for error comes out to be, in this case, $66.70. So what do we have for our interval? Well, the lower end is going to be X bar minus E, our average annual expenditure minus our margin for error. So this is going to be equal to 1306.49 minus 66.70, 1240.24, and the upper limit of our confidence interval is going to be equal to X bar, our average annual expenditure, plus our margin of error of 66.70. You add those two together and you get 1373.64. So what we are saying here in simplest terms is that based upon the sample of 100 prime customers that we are working with, that overall all prime customers, we're 95% confident will spend somewhere between $1,240.24 a year and $1,373.64 a year.